joining us today on HXGN TV. I'm your host, Monica Miller-Rogers. Single photon LiDAR is the next logical evolution of LiDAR, and it has taken the airborne industry by storm. Yet there's still a critical need and demand for linear mode LiDAR. So how did these two come together? Here to discuss that with us further is Ron Roth, Leica Geosystems Manager for Topographic LiDAR. Thank you, Ron, for being here today.
Oh, thanks for the invitation. Pleasure to be here.
So, Ron, let's just start off with what single photon LiDAR is.
Single photon LiDAR is an evolution, as you suggested in your intro, of LiDAR technology. It is very much like radar, uses pulses of optical energy, sends them out, starts a stopwatch, and when the pulse returns back, we look at how much time it took for the pulse to go to the ground and back, and then derive a range measurement from that. The main difference between single photon LiDAR and conventional linear mode LiDAR is that in single photon LiDAR, we use much smaller pulses of laser energy. So as a result, we can have many more pulses each second and still get accurate range information.
And Leica Geosystems this year has released its first single photon LiDAR offering in the SPL 100. What can you tell us about that airborne sensor?
Well, SPL 100 is a product offering based on the technologies of Sigma Space Corporation, a company that Leica Geosystems purchased about a year ago. The single photon technology was developed there over a number of years, but the SPL 100 is our first commercial product offering in that embodiment, that implementation. And as a result, we have the ability to expand the amount of data people can collect and how rapidly they can collect it. So it's a very efficient system, allowing us to collect up to 6 million points per second.
Now, the SPL 100 is not replacing the ALS 80, the linear mode LiDAR sensor by Leica Geosystems. It's still very field proven and very effective in the field. But can you tell us how these two are working together, and when is it appropriate to use the two different technologies?
Oh, absolutely. The two will coexist for the foreseeable future. You can think in terms of these two types of products as delivering an end product that fundamentally looks similar but has slightly different specifications. So for instance, a conventional linear mode system can deliver data that might be accurate to the 3 to 5 centimeter level, whereas a single photon LiDAR might be more in the 6 to 10 centimeter level. Now, that's not to say that 6 to 10 centimeters is bad accuracy. That's still terrific accuracy and is really outstanding when you're using it in large area jobs where you have to collect tens of thousands of square kilometers of data. You want to collect it with high point density and still have reasonable accuracy. So we'll find over time that there is a certain percentage of the jobs that have to be performed that must be performed by a linear mode LiDAR, because those are the jobs with, say, the very highest accuracy requirements and the very highest radiometric fidelity in, say, intensity information. That said, this only accomplishes about 25% of the absorption of LiDAR data each year. So about a quarter of the LiDAR data really has to be acquired by linear mode systems, whereas the other 2/3 to 3/4 of the data that's acquired can be easily and very productively acquired with a single photon system.
There's definitely a need for both, but where do you see the airborne industry going in the future?
Well, what we see in the airborne industry in general is the need to acquire as much data with as much spectral range and as much information embedded in that data as possible. To that end, one of the things that we did with the SPL 100 product is immediately integrated a 4-band medium format camera, an existing Leica Geosystems Geospatial Solutions Division product, and that's now fully integrated with the SPL 100 so that it can fly along and not only collect 6 million LiDAR points per second, but for each one of those LiDAR points, we can ultimately provide red, green, blue, or near-infrared intensity values with it. So more data in each LiDAR point and more points per second.
Well, it's an incredible time to be in the airborne industry. We're certainly going to be watching this to see where it goes in the future. Thank you so much, Ron, for being here and sharing these insights with us today.
Well, thanks for having me.
To learn more about airborne technology sensors from Leica Geosystems, please visit leica-geosystems.com. To see more episodes of HXGN TV, please tune in to hxgntv.com. Thank you for watching.